in my infrastructure, ESXi 1, 2, 3, 4, and 5. And each ESXi host is running 10 virtual machines. Okay, so 10 virtual machines on ESXi 1 in the same way on 2, 3, 4, and 5. Now, I have VM1 on ESXi 1. Now, it wants to communicate with VM50, which is on ESXi 5. Now, how does the communication occur? What are the components which are used in communication? Okay, and how does the communication occur? Guys. 5 ESXi hosts in my infrastructure. Each ESXi host is running 10 virtual machines. And there is VM1 on ESXi 1. Now it has to communicate with VM50 on ESXi 5. So how does the communication occur?
So they have to be in the same network.
Okay, fine.
And same VLAN. I mean, these are different cases.
Okay, fine. So here, how do you build a network basically? Okay, now ESXi 1, 2, 3, 4, and 5 are physical machines, right? They should be in a network, am I right? Now, how do you build that network?
Forming cluster.
Okay. Cluster is not required. Okay. What is required to build a network here now?
So switch and an Ethernet cable.
Absolutely right. What are the three components required to build a network here? The first component you require, IP address is the logical part. Okay. First we'll talk about the devices which are required, the components required. First you require NIC card on each ESXi host, am I right? Now these are my NIC cards, let us explore. Okay, the physical adapters, the NIC cards on each ESXi host. Alright. From there, I require Ethernet cables. And these Ethernet cables go and get connected to a physical switch. And what is there on a physical switch? Ports.
Yeah.
Let us assume we have ports available. Okay, this is my physical switch and this is how they are connected. Alright. So if you want to bring machines in a network, three components are required. You require NIC cards on each and every machine. You require cables, Ethernet cables, and then you require a physical switch. Okay, this is my switch available in my network. Now this is how I have bought my ESXi 1 till ESXi 5 in a network. Okay. Now what about the virtual machines? Now VM1 is on ESXi 1. Now it has to communicate with VM50. What about that? That is a virtual machine. Okay.
We have to assign the IP address in the same network for both the machines.
Okay. But how VM1 is connected to the network now? Only the physical machines are connected to a network. What about the virtual machines?
By using virtual adapters. NIC, virtual NIC.
Fine, absolutely. Why? Because virtual machine is equal to a physical machine, and physical machine has physical hardware, virtual machine has virtual hardware. So that means virtual machine number 1 will have the virtual NIC. Okay, fine. I have virtual NIC card. But where is this virtual NIC card of the virtual machine getting connected?
That ESXi is one's physical NIC card it will use.
It will use, no doubt. But where it is getting connected? Can it get connected directly to the physical adapter? Now again, in virtual networking, if you want to connect your virtual machines in a network, you require three components in virtual. Okay, you have virtual NIC of the virtual machine. Do we have virtual cables?
No.
Assume you have virtual cables. Who is stopping you from assuming? Okay. All right. And then, do we have virtual switches? Yes, we have virtual switches. Okay. So here, try to understand this. VM1 has a virtual NIC card. Okay. It is the adapter. Let us assume that we have cables. Using that cable, it is connected to the virtual switch on ESXi1. Okay. In the same way, these 10 virtual machines are connected to a virtual switch on ESXi2. In the same way, these 10 virtual machines are connected to their virtual switch on ESXi3. In the same way, VM50 is also connected to a virtual switch on ESXi5. Now, virtual machines, we have virtual networking there. These are my physical machines. I have physical networking. But what is the link which will connect my virtual networking with physical networking? My virtual machines are connected to virtual switches. My physical machines are connected to physical switches. But what is the link which is connecting my virtual switch with the physical switch? Or what is the link which is connecting virtual networking with physical networking? Guys, are you getting my point?
A mapping?
Okay, what is the link? What is the component which is connecting my virtual networking with physical networking? Just now, someone answered me.
Mapping?
Oh, no. Someone answered me that. I think Prabhakar or someone, I don't know. Who has answered that? Okay, guys. Here, just now someone told that this virtual machine is going to use the physical adapter on the ESXi1. Who answered that?
That's me.
Okay, now that is the link, guys. Now this physical adapter on ESXi1 is the link which is connecting my virtual networking with physical networking. What is the meaning of it? The same physical adapter which is connected to the physical switch, the same physical adapter is also connected to the virtual switch internally. Did you get my point? So virtual machines will get connected to a virtual switch, and that virtual switch is connected to the physical adapter available on the ESXi host. The same physical adapter is also connected to the physical switch. So the link between the virtual networking and physical networking is the physical adapter available on the ESXi host. So that's how the virtual machines are going to use the physical adapter on the ESXi host for communication with the physical network. Clear? Clear, guys?
Nah.
Yeah.
Yep. Everyone clear? Any doubts with this? It's pretty simple.
Can you come again, please?
Sure. Now, guys, virtual machines have virtual NIC cards. Okay? They get connected to the virtual switch on the ESXi host. Fine? Now, the virtual switch has to communicate with your physical network. How it can communicate? It can communicate through the NIC card which is available on the ESXi host. So what is the meaning here is that virtual machines get connected to the virtual switches. Virtual switch has a link to get connected to the physical adapter available on the ESXi host. This physical adapter is again connected to the physical switch. That's how the network is completed. Virtual network to the physical network. So the same NIC card, this NIC card which is available on the ESXi host is also connected to the virtual switch internally as well as it is connected to the physical switch externally. Clear?
Yes, it's clear, but do we need to create a virtual switch or it's already being created?
That's a good question, Satya. Now, whenever you install ESX or ESXi, it is going to create one virtual switch by default. Okay? We are going to see that in a moment. I'm going to show you that how it is created and what type of connections does it create, so on and so forth. But you understood the concept of virtual network and physical network. How are they interlinked? Clear? Everyone understood this point? Yep.
What is the port capacity of that switch?
You're talking about the virtual?
Yeah, yeah.
Okay, we'll discuss that in detail, not to worry. Okay, fine. Uh, Now let me move forward. We'll try to understand first networking in ESX, then we'll go to ESXi. All right. Can you see a virtual switch? Can we see a virtual switch, guys?
Nah.
Yes, we can't see a virtual
Not
switch. However, when you use vSphere client and get connected to an ESXi host, that virtual switch is represented in a graphical format. That means the virtual switch is appearing in a graphical representation in your vSphere client using the programmatic interface. Why? Because vSphere client is an API, right? It's an application programming interface. So using the programmatic interface, you'll be able to see a virtual switch, and you'll be able to manage a virtual switch. Okay. So here, when you use vSphere client and get connected to an ESXi host, the virtual switch appears in this way. It is a vertical rectangle. It appears in this way, the virtual switch. Okay. And you can see certain left-hand side connections and right-hand side connections on your screen. Technically speaking, yes, Vikas. Yes, raise your question. Vikas, you said you had a question, right? Are you able to hear the voice? What is your question? No, no, it's not like that. Multiple machines, multiple machines can communicate simultaneously. It doesn't mean only one virtual machine. Okay.
What was
Fine.
this question? We can't hear what he asked.
Yeah, he was asking that whether only one virtual machine can be connected via the physical port. He was asking that. No, multiple machines can have communication without any issues. Okay, fine. Now the virtual switch appears in this way on your vSphere client screen. When you use vSphere client and get connected to an ESX host, the virtual switch appears in this way. It's a vertical rectangle, and you find certain left-hand side connections and right-hand side connections. Technically speaking, there is nothing like left hand and right hand. It is only the representation and how it appears on your vSphere screen. It is just for understanding. Okay. Now, on this switch, the left-hand side connections are virtual connections. On the right-hand side, you find physical connections. When I say right-hand side connections are physical connections, what does that mean? What would be connected on the right-hand side?
NIC. NIC of
Absolutely right. Absolutely right. The NIC of the ESXi host. Okay. It is connected on the right-hand side. Fine. This is the NIC of the ESXi host. Okay. The physical NIC. This is on the right-hand side. Okay. On the left-hand side, you find virtual connections. All right. So when you install ESX, as I told you, it is going to create one virtual switch by default, and it is going to take the first available physical adapter, that is the NIC card of the ESXi host, and get it connected to this virtual switch. All right. And on the left hand side, it is going to create two connections by default. The first connection which is created by default here is called as VM network port group. VM network port group. This is the first connection which is created by default on the left hand side. Now, if you see the name of this particular connection, what are you able to understand with this name? VM network port group. What is the meaning of it? What are you able to understand with this name?
Group of network virtual connection.
Yes. Now here, it's a port group, that means group of ports, and the name is saying that VM network, that means virtual machine network. That means virtual machines are going to use this port group to get connected to this virtual switch. Clear? So virtual machines get connected to the virtual machine network port groups. Now why we are calling it as a port group? Because it is group of ports. Okay. VM network port group is a group of ports, and virtual machines always get connected to port groups rather than getting connected to an individual port. Okay. Here the concept of virtual machines getting connected to a virtual switch, they always get connected to a port group, VM network port group. So virtual machines get connected here. Now, what is the second connection which is created by default? Yeah, the second connection which is created by default in ESX is called as service console port. This is the second connection which is created by default on the left hand side. If you see this name service console port, what are you able to understand with this?
Management port.
Absolutely right. Now service console, service, this port is being used to service ESX, that means to manage ESX. Okay. However, if you see this console port, what else are you able to understand? Like ESX has two kernels, right? One is VM kernel. VM kernel's console is hidden, and the other kernel is based on Red Hat Enterprise Linux. And we use the console of Red Hat Enterprise Linux to manage VM kernel. Am I right? So this service console port is nothing but the port of that console operating system. That means Red Hat Enterprise Linux. Okay, and you know that Red Hat Enterprise Linux is running as a small virtual machine on it, right? So this port is nothing but the NIC card of the Red Hat Enterprise Linux, and we are using this port to manage our ESX. So service console port is used to manage ESX. Okay. All right. Clear, guys? Any doubts here? Any doubts? Are you able to understand?
Yeah. Do we need to assign two IP addresses for these two ports? For
Okay, that's a good
VM?
question. The next question I was asking is that where do you assign the IP addresses? On the right hand side, this is my physical adapter, and on the left hand side I have virtual connection. Where do I assign the IP addresses?
Both the sides we have to assign.
On both the sides we have to assign. Okay. Anything else? Guys, the IP addresses are on the left hand side. We don't assign IP addresses on our physical adapter. Here, this physical adapter, which is connected to my virtual switch, act only as an uplink. It is only acting as an uplink, guys. There is no need for me to assign any IP on my physical adapter. All the IPs would be on the left hand side. So the service console port, I assign the IP. Here, let us say the IP address is 10.0.1.50. So this is the IP address by which I am going to manage my ESX. Okay, which has been assigned in the service console port. Normally, I'll ask you a question, guys. Forget about this virtual networking. Suppose you have a laptop or a desktop. Fine. Now, where do you assign the IP address on your laptop or a desktop? On your machine?
NIC TCP IP.
That means you're basically assigning the IP address on the TCP IP stack of the operating system, technically speaking. Right? Basically, we assign the IP address to the TCP IP stack of the operating system, guys. Okay? So the NICs always act as uplink. They bring the traffic, they take the traffic out. So here, this physical adapter which is connected to the virtual switch, we don't assign any IP address here. We are assigning the IP address on the left hand side. This IP 10.0.1.50 which has been assigned to the ESX is actually being assigned to the TCP/IP stack of the Red Hat Enterprise Linux operating system running inside the virtual machine on ESX, and we are going to use this IP to manage ESX. Now let us assume that I have connected a virtual machine number 1 to this VM network port group, another virtual machine VM2 to this VM network port group, okay, and this is VM1, okay, and let us say I have assigned the IP here 192.168.0.25 is the IP of VM1, okay. I am assigning VM2. VM2 has the IP 175.25.10.25. All right. Now, where is this IP address being assigned on VM1? On the guest operating system running inside VM1 in its TCP/IP stack. In the same way, in VM2, the operating system's TCP/IP stack. Clear? Now, the uplink, the physical adapter which is connected to this virtual switch, is connected with an Ethernet cable to a physical switch. Let's say this is my physical switch and it is connected. Now let us say I have a laptop or a desktop connected to this network. Now my question is, can my laptop or desktop communicate with these virtual machines and the ESXi host? Can I communicate?
Communicate, suppose if we are in the same network.
Guys, what about the other guys? Can I communicate?
It won't communicate, man. If it is virtual in the same box, you can communicate. IP address on physical link.
Okay. Who is speaking this? Hari?
This is Satya.
Okay. The other guys, please be on mute. And Satya, yes. Raise your voice. What do you want to say?
Is if you want to speak to outside the world and again as a ESX host, you have a physical link, right? You can speak this 10 virtual machine or 100 virtual machine in the same ESX. But if you need to talk to outside the world, you need to have a physical Ethernet card, right?
Okay. What you're trying to say is that these virtual machines cannot communicate with my laptop? That is what you're trying to say?
Yeah.
Why not? Why not? Why can't they communicate?
How come it communicates without interface? You are not giving any IP to the interface. How come it communicates? And the other thing is,
yes, tell me.
fine. That how come you communicate without a router in over there?
Okay, good. 2 points. Now try to understand this. There is a link here. This link, what is this link? Is the physical adapter available on the ESX host? Yes?
Yes, this is also one of the ports in the switch.
Now this is connected to the switch, am I right?
Yeah.
So suppose VM1 is sending certain packets, those packets enter this virtual switch. From there it enters this physical adapter. From there it enters this physical switch. And that's how the communication occurs. Here there is no need for you to mention any IP address on this physical adapter. Why? Because this physical adapter is only working as an uplink. Always try to understand, guys, the adapters work only as uplinks. It's only a way to bring the traffic and take the traffic out. There is no need for you to assign an IP address. IP addresses are always on the left hand side here. Okay. Now, second point what you have raised is that without a router, you cannot communicate. Yes, when suppose my laptop is having the IP 192.168.0.35. Suppose my laptop is having this IP. Now my laptop can communicate with the virtual machine VM1. Am I right? Why? Because it is in the same network.
Yeah. Yeah.
Yes. Suppose my
Yes,
laptop
yes.
is having the IP 175.25.10.200, let us say. Can I communicate with VM2 now?
We can communicate.
Yes. Now suppose my laptop has the IP 10.0.1.200. Can I communicate with ESX now?
No.
Yes, we can communicate.
Yes, I can communicate with ESX. Why? Because
Yes,
ESX is
yes.
having the IP address 10.0.1.50. However, if VM1, VM2, and this ESX 10.0.1.50, if they want to communicate among themselves, then there should be a router which is configured. Okay, do you understand? Suppose my laptop has an IP 10.0.1.200. Now my laptop wants to communicate with VM1, which is 192.168.0.25. Then there should be a router here configured. Are you getting my point, guys? There should be a router in your network. Okay, and using that router, I would be able to communicate. Let us say this is my router. If you have a router connected in your network and NATing done, then the communication can occur from 10.0.1.200 to 192.168.0.25 or 175.25.10.25. Got the point, guys? Got the idea? Clear? Doubts are clear? Or still have any doubts? If you have any doubt, please raise the question and let us clear it off, because these are the fundamentals on which we are going to build the future knowledge. Whatever clear with the concepts?
Is this a special technology, something like that? Uplink is in VMware. Like I'm talking about regular technology, not talking about this uplink. Usually, if you want to communicate anything, you need to have physical internet. So
I guess someone is not on mute. He has Zoom online training. Oh, Zoom online one training host. He is not on mute. Srinivasji, are you here? Okay, thank you. Thank you so very much. All right. Okay, now, guys, here normally try to understand that we assign the IP address to the TCP/IP stack of the respective operating system. Okay. It is normally on any of the technology, whether it is you are using Windows, Linux, whatever it is. The IP address is logical basically. Okay, and we are assigning this IP address in the TCP/IP stack of the respective operating systems running on it. Always the NSE cards act as uplinks. They only bring the traffic and take the traffic out. Okay. No doubt NSE card is required. Why? Because TCP/IP stack, when you want to assign an IP address to the TCP/IP stack. But usually, yeah, Rupesh, I'm unable to hear you. Please raise your question. You have a question, Rupesh? Okay.
Single connection is enough for router? This one?
That means the router which I have configured here?
Yeah.
Like a single
Normally
connection
in
is...
router at least minimum we have two connections.
Yes. Okay.
Will use for both the networks, it will use the same port.
No,
Actually,
basically
here we have
you
three
have two
networks.
lines. Okay, you have
Yeah,
two or
here we
three,
have
whatever the
three.
lines. Okay,
Okay.
fine. So one would be configured with one IP, the other one would be configured with other IP, the third one
Yes.
would be configured with third IP in that way. Okay,
Oh,
fine.
other two also connected to the same switch.
Yeah, yeah. It may be connected
Yeah.
to the same
Okay.
switch or some other switch, whatever it may be, but they are in a network. Okay, fine,
Okay.
fine. So this is how we are going to have the communication in ESX, and the IP address which we are assigning to ESX is the IP address which we have assigned to the service console port here 10.0.1.50. All right. Now in ESX there is a third type of connection on the left hand side which is not created by default. By default, ESX is going to create two connections on the left hand side. One is VM network port group, the other one is service console port, and there is a third connection which you have to create manually on the left hand side. And what is that connection? Let us see. The third connection which is created by kernel port. Okay. Now we know that on the left hand side each connection is used for one particular task. For example, VM network port group is used for the virtual machines to get connected. Service console port is used for management. In the same way, VM kernel port is also used to handle some kind of traffic. Now let us see what are the traffics which your VM kernel port is going to handle on the left hand side. Now VM kernel port handles iSCSI traffic, iSCSI SAN traffic. Okay, it also handles NAS traffic. It also handles vMotion traffic, and it can also handle fault tolerance traffic. These are the four kinds of traffic which your VM kernel port is going to handle. Okay, and keep this in mind, every VM kernel port needs to have a valid IP. You need to assign an IP address to a VM kernel port. Okay, and this VM kernel port can be used for iSCSI, NAS, vMotion, and fault tolerance, but it is not recommended to use one VM kernel port to handle all these four kinds of traffic. You can create multiple VM kernel ports, and you can dedicate one VM kernel port for one kind of traffic. However, every VM kernel port requires an IP address. Now, this is the third type of connection which is available in ESX, and you have to create it manually. Clear, guys? Clear? You understood VM kernel port and what it handles, what kind of traffic it handles in ESX? It handles
Yep.
iSCSI, which is SAN traffic, NAS traffic, vMotion traffic, and fault tolerance traffic. So you can have four different VM kernel ports to handle four kinds of traffic. Okay, and every VM kernel port which you are creating, you need to assign an IP address to it. Now let us see how does a virtual switch is configured in ESXi, and what are the right hand side connections and the left hand side connections. Let us try to understand that. All right, now let me do one thing. Let me create that switch. Guys, I told you when you install ESX, one virtual switch is created. In the same way, when you install ESXi, one virtual switch is created by default. This is ESXi. That virtual switch is also similar. It appears as vertical rectangle. Okay. And this also has left hand side connections and right hand side connections. What would be on the right hand side, guys? Right hand side, same physical NIC, the uplink. Physical NIC, the uplink. Okay. So it is also connected to your switch in this way. All right. On the left hand side, you find virtual connections. So could you tell me what could be the difference here in ESXi when compared to ESX?
We don't have a service console port.
Service console port.
Absolutely right. We don't have a service console port in ESXi. Why? Because there is no console operating system which is based on Red Hat Enterprise Linux. So when you install ESXi, one virtual switch is created by default. So ESXi is going to take the first available NIC card on that ESXi host and connect it as an uplink to this virtual switch. And on the left hand side, two virtual connections are created. The first connection which is created is VM network port group. Okay. Port group. And the second connection which is created by default. What could be the second connection, guys?
VM kernel port.
Yeah, it would be the VM kernel port. So this VM kernel port, which is created by default, is used for management. Is used for management, and it is called as management network. What is the meaning of it? This VM kernel port, which is created by default, is used to manage ESXi. So the IP address which you are assigning to your ESXi would be the IP address which you are assigned to this VM kernel port. Okay, and let us say the IP address what I have assigned here is 10.0.1.20. Okay, now here in ESX, VM kernel port handles iSCSI, NAS, vMotion, and FT traffic. But in ESXi, this VM kernel port handles 5 types of traffic. Why? Because management traffic is now being handled by the VM kernel port itself. So the first kind of traffic which is handled by VM kernel port is management. Second, it handles is iSCSI. Third, it handles is NAS. Fourth is vMotion. And the fifth is fault tolerance. So in ESXi, yes.
So who handles the management traffic in ESX?
ESX service console port handles the management traffic.
Okay. Okay. Sorry.
Okay. Yes. Now here in ESXi, the VM kernel port handles the management traffic, the iSCSI, NAS, vMotion, and fault tolerance. However, the first VM kernel port which is created by default, the first VM kernel port which is created by default here, the first VM kernel port which is created by default handles management. It can also handle iSCSI. It can also handle NAS by default. Okay. However, for vMotion and fault tolerance, you can use the same port, but it is not recommended. You can create some other VM kernel ports, to handle vMotion and fault tolerance. Okay, and you can also create another VM kernel port for iSCSI and NAS as well. However, for every VM kernel port, you need to assign an IP address. Clear with it? Clear, guys? Any doubts? Any doubts, guys, before I move forward? All right. This is how networking is achieved in ESX and ESXi. Okay. Let me go back to the slide and then come back with certain scenarios where how to create virtual networking depending on our requirement. Okay. Now, virtual networking, guys, here the virtual machines have virtual network adapters, and using these network adapters, virtual machines get connected to the virtual switches. These virtual switches get connected to the physical network adapters available on the ESXi host. The same physical network adapters get connected to the physical switches. That is how the virtual networking and physical networking is complete. Clear with the concept? Okay. Now, guys, let us see a scenario where we have to build virtual networking on our ESXi. Okay. And how to build that virtual networking, how to create that virtual switches, so on and so forth. Before that, let us try to understand the difference between a physical switch and a virtual switch. Okay. Now, guys, what do you find on a physical switch?
Ports.
Ports. In the same way, you find ports on virtual switches as well. Okay. Now, in OSI layers, normally physical switch functions at which particular layer?
Layer 2.
Layer 2. As physical switch is a layer 2 device, virtual switch is also a layer 2 device. In most of the cases, physical switch and virtual switch are common. They are the same. They function as the same. However, there are one difference. Okay, one or two differences. I'll explain that. Okay. Now, physical switch forward frames, virtual switch also forward frames. The ports on the physical switch can act as access ports and trunk ports. In the same way, ports on virtual switch can also act as access ports as well as trunk ports. Fine. However, physical switches can be interconnected among themselves. Am I right? You can connect one physical switch with another. Can I do that?
No.
Can I connect one physical switch with another? Can I connect them?
Yes,
Yes.
yes, we can connect.
So interconnection of physical switches is possible, whereas you cannot connect two virtual switches together. There is no link between one virtual switch and another virtual switch. Guys. That is one difference. Suppose I have created one virtual switch. I created another virtual switch on the ESXi host. There wouldn't be any communication between this switch and this switch internally. I cannot connect two virtual switches together, whereas I can connect two physical switches together. No link here. Okay. In virtual switches, two virtual switches cannot be connected together, whereas physical switches can be connected, right? As physical switches are connected together, they can be connected among themselves. Physical switches use spanning tree protocol. Guys, you understand STP? There is a protocol used in our physical switches called spanning tree protocol. How many people know about STP, guys? You all know about STP?
No, we don't know.
Okay, Satya doesn't know it. What about the other guys? Okay, let me try to explain you spanning tree protocol in a basic way. Right, let us assume that I have physical switches in this way. Okay, now these physical switches are connected in this way. Let us assume they are interconnected among themselves. And these are also connected in this way. Let us assume. Okay, and let us assume this this physical switch has 20 ports. Okay, all this physical switches has 20 ports. That means 20 systems can be connected. Okay, let us assume. Now there is system number 1 here on the switch number 1. Okay, system number 1 on switch number 1 wants to communicate with system number 120 on switch number 6, let us say. Now, the packets from system number 1 has to travel to system number 120 on switch number 6. Now, there are multiple ways how I can reach system number 120. One, I can travel in this way. The packets can travel in this way and reach the destination. Packets can travel in this way and reach the destination. Packets can also reach in this way, right? Now, every physical switch has this protocol, spanning tree protocol, and there is an algorithm which runs behind the scenes, and it will run and calculate the shortest possible path to reach the destination. Okay, so if you see this network, which is the shortest path to reach system number 120 here? This way, or this way?
Diagonal.
Diagonal. This is the shortest path, right? So the spanning tree protocol on this physical switch will find the shortest path to the destination, and there are two other ways, right? This is the one way and this is the other way. What spanning tree protocol is going to do is that it is going to block these two connections. Okay, the redundant paths are blocked and it will find the shortest possible path. Okay, so that's how spanning tree protocol functions. Now, spanning tree protocol is used because switches are interconnected among themselves. Now, there is no requirement of spanning tree protocol in virtual switches. Why? Because there are no loops. There are no multiple redundant paths. There are no multiple paths. Why? Because one virtual switch is not connected to another virtual switch. Am I right? So there is no question of loops. There is no question of multiple ways. So no requirement of STP. So there is no spanning tree protocol used on our virtual switches. Clear? Clear, guys? Did you get the concept? On the virtual switches, I cannot connect two virtual switches together, as multiple virtual switches are not interconnected among themselves. They don't require spanning tree protocol. This is the first difference, guys. And now let us try to understand another thing here. Now every virtual switch needs to have at least one physical adapter connected to it as an uplink. Am I right? This is a virtual switch. On the right hand side, a physical adapter is connected to it and it is acting as an uplink. Okay. In the same way, this is my second switch. It also has an uplink, which is the physical adapter. Now, every virtual switch needs to have its own dedicated physical adapter acting as an uplink. This uplink, one physical adapter cannot be shared with two virtual switches simultaneously. Did you get my point? So that means every virtual switch needs to have its own dedicated NIC card, physical NIC card from the ESXi host acting as an uplink. Suppose if I have only one NIC card on my ESXi host, that NIC card cannot be connected to two virtual switches simultaneously. Did you get my point, guys? These are the differences of physical switch and the virtual switch. Other than this, physical switch and virtual switch functionally are equal. Both are layer 2 switches, both forward frames. The ports on both the switches act as access ports and trunk ports. Everything is the same. The difference is there is no spanning tree protocol used on virtual switches because they cannot be interconnected among themselves, and the uplinks cannot be shared between two virtual switches. Every virtual switch needs to have its own uplink. Clear? Clear, guys?
Mujab, I couldn't understand. Your voice has been flooded. I can't hear properly. Can you come again, please?
Okay. Now here, did you get the point of STP? There is no requirement of STP on the virtual switches.
STP I got it, but after that I couldn't get it. Your voice has been flooded.
Fine. After that, here is that every virtual switch requires one physical adapter acting as an uplink to it. Suppose I have only one NIC card available on my physical server, that means on an ESXi host. So this adapter cannot be shared between two virtual switches as an uplink. Every virtual switch needs to have its own uplink. So uplinks cannot be shared between two virtual switches. Clear?
Clear.
All right. Fine. So this is the difference between a physical switch and a virtual switch. Now let us try to understand a networking scenario. Before that, let me explain you that in real time, the ESXi servers will have multiple NIC cards available on the ESXi host. Maybe you find a server which is having 6 NIC cards, 8 NIC cards, 10, 12, 15, maybe 20 NIC cards available on each ESXi host. I'm talking about the physical adapters, the physical NIC cards. Now, why there is a requirement for so many NIC cards on an ESXi host? Normally, on a physical server, if you're running an operating system like Windows or Linux directly on it, maybe 2 NIC cards are quite sufficient for it. But ESX or ESXi host is not a normal host or not a normal server. It handles many kinds of traffic. Now, let us first try to understand what are the types of traffic which your ESXi host is going to handle and why there is a requirement of having so many NIC cards on our ESXi host. First, this is my ESXi server. Okay. What is the first kind of traffic which comes and goes outside of the ESXi host? The first kind of traffic which comes and goes outside of the ESXi host is the management traffic. The management traffic by which we manage this ESXi. Management traffic means traffic coming from vSphere client or web client. When you use vSphere client and get connected to ESXi host and manage it, that is what the management traffic. So I can call it as management network. This is the first kind of traffic which comes and goes outside of your ESXi. Then, what are we doing with this servers, ESXi servers? We are creating virtual machines, right? Okay. Let us assume that this is I have VM1 on it, and I have VM2, let us say, and I have operating system running on it. Suppose let us say this is Windows, okay, and here I'm running, let us say, Linux. On Windows, I'm running a service called Active Directory. Here, let us say, I'm running Oracle database. Okay, so the traffic associated with Active Directory and traffic associated with Oracle database is also coming and going outside of my ESXi host, right? So that means traffic associated with virtual machines is coming and going outside of the ESXi host. So the second kind of traffic which is coming and going is the traffic associated with virtual machines, that is VM network traffic. This is the second kind of traffic. Now, guys, yesterday we tried to understand what is a virtual machine from the perspective of operating system as well as from the perspective of ESXi. What is a virtual machine from the perspective of ESXi, guys?
Operating
What is a
system.
virtual machine? What is a virtual machine from the perspective of ESXi?
It's a
Files in
folder.
a folder.
Folder.
Yes, it is nothing but set of files stored in a folder, and that folder can be stored on a hard disk. That hard disk can be a local hard disk, and that hard disk can also be a shared hard disk. Where do you find shared hard disk, guys? On SAN, am I right?
On the network.
On the SAN, storage area network, right? This is my SAN. And virtual machines are nothing but set of files stored in a folder, and that folder is getting stored on my hard disk, whether it is local or on SAN. Let us say VM1, VM2. That means there is continuous traffic from ESXi to your SAN, because your virtual machines are stored on your SAN. So the third kind of traffic which is coming and going outside of your ESXi is the SAN traffic. SAN or NAS, whatever it may be. SAN. Now, the fourth kind of traffic. We discussed about vMotion, right? What is vMotion? What is vMotion, guys?
Moving a
Yeah.
virtual machines from one host to another.
Yeah, migrating a running virtual machine from one ESXi host to another ESXi host. Right? So vMotion traffic is also a kind of traffic. So the fourth kind of traffic is vMotion traffic. Then the fifth kind of traffic which is coming and going outside of the ESXi host is fault tolerance. Fault tolerance is a concept in clustering. We'll discuss that in clustering, but it also involves huge traffic. So that is called as fault tolerance traffic. So there are totally 5 kinds of traffic coming and going outside of the ESXi host. First one is the management traffic, second virtual machines traffic, third SAN traffic, fourth vMotion traffic, fifth fault tolerance traffic. Now normally one NSE card may not be sufficient to handle all these kinds of traffic. That's the reason why we require more NSE cards on an ESXi host. Sometimes you might find servers having 4, 6, 8, 10, 12, 15, 16 or 20 NSE cards available on one ESXi host. And that's the reason why you require more number of NSE cards. However, now the original equipment manufacturers, the server manufacturers are coming up with 10 Gbps cards. If you have 10 Gbps cards, maybe 2 NSE cards are quite sufficient, because overall you get a bandwidth of 20 Gbps. If you have 1 Gbps cards, then maybe you require more number of NSE cards, maybe 6, 10, 15, 16, 20, depending on it. Did you get the logic, guys? Clear?
Yeah.
Clear, guys? Now let me take one example, one scenario of how to build a virtual network, okay, by creating different virtual switches, and how to segregate the traffic by bandwidth, and how to segregate the traffic using VLAN configuration. Okay, let me take that example. Let us assume that there are 20 virtual machines on my ESXi server. Okay, and I don't have a 10 Gbps card, I have 1 Gbps card. Okay. For every 5 virtual machine, I want to dedicate one NIC card. Did you get the concept here? I have 20 virtual machines on an ESXi server, and I have 1 Gbps cards available on the ESXi server. I want to segregate the traffic. I want to segregate the bandwidth. For every 5 virtual machines, I want to dedicate one NIC card. How can I do that? How can I achieve it? Okay, let us have a look here. Guys, we know that when you install ESX or ESXi, it is going to create one virtual switch. On the right hand side, you have one NIC card which is acting as an uplink. Right? On the left hand side, you have VM network port group. And I told you virtual machines will always get connected to VM network port group. So I connect 5 virtual machines to this port group. 1, 2, 3, 4, and 5. Let us say VM1 till 5 are here. Till VM5. Okay. And now all the traffics of VM1, VM2, VM3, VM4, and VM5 is coming and going outside of this physical adapter, which is acting as an uplink to it, right? Clear, guys? Yes, that means I have dedicated this uplink to these 5 virtual machines. Now you want to dedicate another 5 virtual machines to another NIC card. What do you have to do that? You have to create another virtual switch, guys. Create another virtual switch. Take the other NIC card which is available on the ESXi host and connect it as an uplink. Create a VM network port group on the left hand side. Now connect the other 5 virtual machines. Let us say VM6, VM7, VM8, VM9, and VM10. Okay, now these 5 virtual machines from VM6 to VM10 are using this uplink, the second adapter. So that's how I have dedicated 5 virtual machines, one NIC card. What about the other 5 virtual machines? Create another virtual switch. Okay, in the same way, give an uplink, create a VM network port group on the left hand side on this virtual switch, and connect the other 5 virtual machines here. Okay, here you have VM6 to VM10 are connected here. In the same way, connect VM11 to VM15 to this particular port group. Okay, and this is how you are segregated. What about the other 5? Create another virtual switch. On the right hand side, use another NIC card. On the left hand side, you create a VM network port group and connect VM16 to VM20. So this is how you have segregated the bandwidth. Okay, and for every 5 virtual machines, you have dedicated one NIC card. Clear? Did you get the concept, guys? This is how you have to build your virtual networking based on your requirement. Clear? Clear, guys? Any doubts? Now, suppose you want to segregate the traffic using VLAN technology. Okay, there's a concept of VLAN as well. As I told you, the ports on your virtual switch can act as access ports as well as trunk ports. Okay, now suppose this is my switch, and you want to assign a VLAN to 5 virtual machines. Okay, we know that virtual machines will always get connected to port group. So there is one port group which is available. Okay, and here it is my VM network port group. Now assign the VLAN ID here. Suppose you have assigned the VLAN ID number 10. I've assigned the VLAN ID 10 to this particular port group. Then all the virtual machines which are connected to this port group will get the VLAN ID 10. Okay. In the same way, you can create another VM network port group and assign the VLAN ID maybe 15. Then all the virtual machines which are connected to this VM network port group will get the VLAN tag 15. Okay. In the same way, another port group, and you want to assign another VLAN ID here, VLAN tag, and group certain virtual machines without VLAN. Then assign the VLAN ID, maybe let us say VLAN 20. Then all the virtual machines which are connected to this port group will get the VLAN tag 20. Right? This is how we can configure VLANs on our port groups on the left hand side. Again, keep this in mind, guys. We configure VLANs on our virtual switches, on the port groups, or on the individual ports only if you have VLANs configured on the physical network. First, VLAN is configured on the physical network. Then, accordingly, we configure VLANs on our virtual network, guys. Keep this in mind. We don't configure VLANs on our virtual port groups if we haven't configured VLANs on our physical network. First, VLAN is configured on the physical network. Then, accordingly, we configure VLANs on our virtual network. That means on our port groups. Clear with the concept, guys? Clear?
Clear, Mujab. I have one question.
Yes.
Is it possible I can make it VM5 and VM10 and VM15 and one VLAN?
That means multiple VLANs in a single port group, you are asking me?
No, the VLAN is the concept like we can communicate with the different boxes. We can communicate only that thing, right? Those three boxes, if I'm doing in physical network. You are saying that you are creating VLAN and a group, the whole group virtual switch. Is that possible that I'm asking VM5 and VM10 and VM15 should be in one VLAN group?
Yeah, you can do that. Yes, but try to understand this. Here there is a concept of port group. Okay.
Yeah, that's what I'm asking. Is it possible?
Oh, you're asking me what? Could you repeat the question?
See, we have 5 virtual machines in each and every switch, right?
This is different scenario. This is different scenario.
Yeah, that's what I'm saying. Like we have VLAN 10 you're viewing from VM1 to VM5.
See, no, it's not like that. It's not like that. Okay. I configure the VLAN on a port group. Okay. Okay. Now I can connect virtual machines here. Let us say virtual machine number 1, virtual machine number 10, virtual machine number 15 can be a part of this VM network port group.
Okay, that's what I'm asking.
Guys,
can't we assign each port to different VLAN? Actually, can't we assign each port?
This is a separate scenario, and this is a separate scenario. Okay. Now here, VM network port group, I can configure a VLAN on a port group, and whatever the virtual machines I get connected to this port group will get that VLAN ID. Suppose it is VM1 will get the VLAN ID 10, if it is connected to VM network port group. This is VM15, this is VM20. All these virtual machines will get the VLAN ID 10. Okay. If you are connecting the virtual machines to this VM network port group, then whatever the VLAN which is configured here, they'll get that particular tag. The same way, this particular VM network is having VLAN 20. Then what are the virtual machines which are connected to this particular port group will get the VLAN tag 20. Clear? Clear? Now, what was the other question? Someone is asking some other question. What was the question, guys? Is it clear, guys? Did you get the concept? Any questions here?
Yeah, how to assign the port to particular VLAN? You said we have to create VLANs in the physical switch. Normally in physical switch, we will assign the ports. Suppose particular port 1922 to VLAN 10, 3 and 4 to VLAN 20, like that we will assign.
Yes.
How to assign these virtual machines to that particular VLAN? Corresponding port number only?
Yeah, that's what. Here, guys, virtual machines, keep this in mind. Virtual machines will always get connected to virtual switches. Right?
Yeah.
Now, on the virtual switches, you have virtual machine network port groups. Okay, and these port groups can act as access ports, trunk ports, and you can also assign VLAN ID here. Suppose I have configured VLAN 10 to this VM network port group, then all the virtual machines which are connected to this port group will get the VLAN tag 10. Clear?
Okay.
Okay. And what was your question? What was your doubt?
Yeah, then that particular uplink port we have to configure into that particular VLAN. We have to assign.
Okay.
Yeah, that's
Okay.
it. No?
Just have a look here. This is my uplink, right?
Yeah.
Now this uplink is connected to my physical switch.
Yeah, some
Okay.
port number 2 or 3 something.
Whatever it may be. Okay.
Yeah.
Now here, this virtual switch is having multiple port groups and multiple VLANs. Am I right? VM network port group VLAN 10, VM network port group number 2 VLAN 15 maybe another port group with VLAN 20, right? All these VLANs and traffic is coming and going outside of the same uplink. Am I right?
Yes. Yes.
Now this uplink is connected to the physical switch.
Yes.
There is a port, and here this port should be configured as trunk port. Did you get my point?
Yeah.
Now you should configure it as trunk port on the physical part.
Okay.
Then only it can handle the traffic associated with multiple LANs. Suppose there is only one VLAN here, and you want to make that only one VLAN has to communicate, then make sure that this port is also of that particular VLAN. Okay?
Oh, okay.
Clear with the concept?
Yeah.
Yes. Any other doubts, guys? Any other question?
So what is the capacity of virtual switch?
Guys, it has great capacity. The minimum ports are 8 and the maximum ports are 4088 usable ports. 4088 ports on a switch, guys. Alright? You don't find such kind of a physical switch available in the physical world with 4088 ports. But you have a virtual switch which can have a maximum of 4088 ports. Alright? You'll be able to see that. Yes, Rupesh. What is your question? How does the physical switch forward the request to? To the right uplink. Okay, it maintains the MAC address tables, guys. It maintains the MAC address tables. You need to understand that. Okay, Rupesh. Every physical switch maintains MAC address tables. Using those MAC address tables, they forward frames. In the same way, virtual switch also maintains MAC address tables, and using that, it forward frames. All right. Can I move forward, guys? Okay, fine. So this was all about your virtual networking, guys. Okay, and let me inform you one more important point here regarding the port group labeling, guys. Guys, the port group label by default, when the virtual switch is created, it creates the left-hand side connection, and that particular port group name would be VM network. Okay, and the labeling plays very important role in virtual networking. Okay, you can rename that particular label. You can go in this way, guys. In real time, you may label that VM network port group with production, so that production virtual machines can be connected there. So just by seeing that particular label, we come to know that okay, virtual machines which are a part of production are connected to this particular port group. You can also label the port group with development, so that development virtual machines can be connected and segregated to a separate port group. The same way, you can name the port group with test, so the test virtual machines can be grouped and they can be connected to a port group. In the same way, you can also label the port group by applications. Let us say you are having certain 5 or 6 virtual machines running Exchange server. So you can label that particular port group with Exchange and see that all those 5 or 6 virtual machines are connected to that particular port group. So port group labeling plays very important role, and you can label the port group according to your requirement, maybe production, test, development, based on application, maybe database, Exchange, SAP, in that way. So port group labeling plays very important role. and I'll discuss about the importance of port group labeling in vMotion while we discuss the vMotion concept. Okay, so we can also label it with different requirements according to your requirement in your infrastructure. All right. So let me move forward from here. Now, guys, this particular slide which I have prepared, keeping in view of certain freshers who didn't got an opportunity to work in an organization, they didn't get an opportunity to see what are the components available in your data center, what are the different components used, and what type of servers are used, so on and so forth. So this is for those who don't know what type of servers are used in real time, so that they get an idea, so on and so forth. So let us see virtual data center infrastructure, guys. Now, guys, in our data centers, we use our servers, and these servers are of different types. Okay, the types of servers used are tower servers, rack mount servers, and blade servers. Now, how many people know about these servers, tower, blade, and rack mount servers? Anyone has idea?
No, but the
Guys, do
blade
you have
servers,
idea?
but not the other one. Rack mount, I suppose, is the normal
Yes.
server, which is the IBM servers or the Intel servers, which actually mount in the racks.
Okay.
And tower
Any other guys
servers,
who don't know about these servers?
No, I don't know any. I don't have any idea about this server.
Okay, Prabhakar. Okay, was it Prabhakar? Okay, anyone else?
So blade servers are like they are in a chassis, and rack mount servers are individual blades.
Okay, fine. Fine. Now let me explain you guys why these servers are called as tower servers, rack mount servers, and blade servers. Guys, any component in IT gets its name based on its appearance and its usage, guys. Okay. Now, basically, we are Indians, and our mother tongue is not English, right? Our mother tongue may be something else, maybe Hindi, Telugu, Urdu, Tamil, Malayalam. Fine. Now, any technology in IT or any component in IT will get its name based on its usage and its appearance. Keep this in mind. Now, guys, how many people, when you heard for the first time what is a server, okay, you heard for the first time this term called server. How many people got confused? What is this server? Everyone agrees that they got confused. They don't know what is the server, right? When you started learning IT and when you heard for the first time what is a server, how many people understood what is a server in the initial stage itself?
It shows different type of applications.
Yes, but why this particular thing got its name as server? Did you understand in the
Server,
beginning?
actually, in hotel, server will serve all the items. So I think the same way the server will serve the items to client.
Yes, guys. Here, just try to see the spelling. Okay, server. Remove R. What is this? It serves, right? It serves the request. So that's the reason why this particular component got its name as server. I told you, any component in IT, any technology in IT will get its name based on its usage and appearance. Keep that in mind. In the same way, when the first time you might have heard the name of router, you got confused. What is this router? Remove R from here. What is this? Root, right?
Yeah.
What router does basically, it routes. It finds the way to your destination. That's how these technologies, these devices got its name based on its usage and appearance. In the same way, a tower server got its name as tower because it appears as a tower standing straight. Because of its appearance, it got its name as tower server. Okay. When it comes to rack mount servers, these servers gets mounted on a rack, and that's the reason why these are called as rack mount servers. And again, you find rack mount servers. Some people say rack mount 1U server, 2U server, 4U server, 5U server, and rack mount 6U server. What is this 1U, 2U, 4U, 5U, and 6U? It is nothing but unit. It is a unit which is occupied, the space of unit which is occupied in a rack. One unit server That means it's small, sleek, and it occupies 1 unit in your rack space. 2U server, it occupies 2 units. 4U server, it is quite bigger and it occupies 4 units of space. In the same way, 5U occupies 5 units and 6U occupies 6 units. So that's how these rack mount servers got its name as rack mount, and based on its size and based on the size they occupy on a rack, they got its name as 1U, 2U, 4U, 5U, and 6U. In the same way, blade servers. Now these servers, blade servers got its name as blade because they are small, like they are sleek like blades. Okay, you have a razor blade, right, which is very sleek, and you know that nowadays you are coming across these kind of machines, uh, the Gillette shaving machines or 7 o'clock shaving machines, where you have the handle fixed and on top you have the blade which is easily replaceable. Whenever you find that this blade is not no more functioning, you can just unplug it and plug the new one. Okay, easily replaceable, hot pluggable, plug in and plug out. Now here, blade servers are are in a chassis. Someone was talking about, that is what, right? There is a chassis, guys, and there are slots in that particular chassis, and these blade servers are sleek and they go and get fixed in those slots. Now you need to understand one thing: in tower servers and rack mount servers, all the cabling, all the cables, the power cards and the networking cards are connected to the servers directly. But in blade servers are usually mounted or get fixed in a chassis, and all the power cables or power cards and the networking cards are getting connected to the chassis, not individually to the blade servers. Internally in the chassis, there would be connections like docks. There are docks available, and these blade servers goes and get fixed in that particular docks where there is power supply from those docks as well as networking supply to those docks. So based on the usage and appearance, these servers got a name as tower servers, rack mount servers, and blade servers. All right. And guys who don't know anything about these servers, I suggest you to just Google and see certain images of rack mount, tower, and blade servers, and you'll have an idea, better idea. And in my lab, in my infrastructure, what Zoom is providing, you have HP blade servers, guys. So your practice would be on HP blades. Fine. Now, this was about the type of servers used in our infrastructures. Okay. And then you have network being used in our infrastructures. We have different types of network. We use Ethernet networks. Nowadays, fiber optic is becoming very common. Uh, and obviously you require switches, routers, firewalls in your network in order to interconnect them and to see that they are secure. And centralized storage, guys. Centralized storage has become an integral part of our data centers nowadays because of virtualization. Now, with virtualization getting implemented in each and every infrastructure, whether it is small, medium, or large, centralized storage has become an integral part. Now, in centralized storage, you have SAN, storage area network, okay, and you also have network attached storage. These are two types of storage technologies used in our networks. We are going to discuss in detail the difference between SAN and NAS in our storage class, not to worry. However, storage area network is a shared storage as well as NAS is also a shared storage, and you can also call them as centralized storages. In SAN, you have again different type of SAN like FC SAN and iSCSI SAN. We are also going to discuss about FC and iSCSI SAN in detail in our storage class. Fine. And let me move forward from here. Any doubts with this centralized storage or type of servers? Can I move forward?
iSCSI, can you would you be explaining the in detail as well?
Basically, in storage technologies, you have SAN, storage area network, and there are different protocols used in SAN. One protocol is FC SAN, fiber channel. The other one is iSCSI SAN. These are protocols, not to worry, used in our SAN technology, in our SAN network. I'm going to discuss in detail about FC, iSCSI, FCOE, these kind of technologies, even NAS, in detail in our storage class. But just try to understand this is a storage technology used in our SAN, iSCSI SAN. Okay. Now, as virtualization in place, the most important component is your server virtualization software, which is your hypervisor. In our case, it is VMware vSphere, which allows you to create virtual machines, virtual networking, and virtual storage. Fine. And then on our virtual machines, we install our guest operating systems. And on top of your guest operating system, you install applications. And if it is a data center and you want to connect your data center from a remote location, you require internet. Again, internet is classified into two types basically, leased lines and broadband. Guys, do you understand the difference between leased line and broadband type of internet connections? What is the difference between leased line and broadband?
This line is a dedicated line, broadband is a
Yes. Now, guys, those who don't know the difference between leased line and broadband, guys, here it all depends on the bandwidth, guys. In leased lines, the bandwidth is dedicated, and in broadband, the bandwidth is shared. Okay, and organizations use these lines normally. Previously, we used to use E1 and T1 lines. E1 and T1 lines are nothing but telephone lines, basically copper telephone lines. And E1 is a standard of European standard, and in India we use E1 telephone lines. In America, we used to use T1 lines. However, nowadays we are using fiber optic, fiber optic cables for leased lines as well. And VPN, virtual private network, to have a secure connectivity from any part of the world to your data center. We can have VPN, virtual private network. It can be based software based VPN or hardware devices based VPN, whatever it may be. So, and nowadays cloud computing software is also becoming an important component in your virtual data center infrastructure. Certain softwares are used to build private and public cloud. VMware also develops a cloud computing software which is called as VMware vCloud Director. Using this software, we can build a private or a public cloud. So these are all your software and hardware components which are used in our data centers, in our data center infrastructures nowadays. Clear, guys? Clear? All right. Fine, guys. Now you want me to continue or can we continue tomorrow? Well, because the next topic is entire theory and we'll try to understand how ESXi virtualizes the CPU and the memory. Okay. And as it is a theory part, maybe you'll get bored and maybe you'll not catch up the concepts. I suggest we'll take up this topic freshly tomorrow. Is it okay?
Yeah, okay.
Yep. We'll end the session for today, guys. I don't want to take up this ESXi virtualization. Why? Because it is very important for you to understand how ESXi actually virtualizes the resources available on it. Okay. And how exactly virtualization has been achieved using this VMware technology. What exactly this ESX and ESXi